Hello and welcome back. In this video we are going to talk a little bit about broadcast domains and the purpose of a router. So this is an important concept to understand for a network engineer, obviously. First of all, what is a broadcast domain? A broadcast domain is a logical division of networks in which broadcasts can be received by any device connected to it. Routers are what separate these domains. Broadcasts are sent to every device on a network, so if your network is made up of nodes and switches, you likely have only one logical network and therefore one broadcast domain. If your network is made up of nodes, switches, and routers, you will likely have more than one broadcast domain. Routers divide networks and route traffic between them. The router is the boundary between networks. So if you think of it in terms of logical networks, if your topology contains three networks, say 192.168.1.0, 192.168.2.0, and 192.168.3.0, you have three broadcast domains. Or if you have multiple subnets in your network, each one will be on its own broadcast domain. You can think of it in terms of links as well. If your two routers and two switches are connected to a router with nodes connected to each switch, each link on the router will be in its own broadcast domain. Broadcasts sent out from a node on one side of the router will not pass through to the other side because the other side is on a different network and therefore a different broadcast domain. Now let's talk a little bit about collision domains. So an Ethernet collision domain, as opposed to a broadcast domain, is a network segment where packets and frames can collide with each other on a shared media. A collision can occur when a packet is sent over the same media by multiple devices at the same time. This used to be more of a problem in past years when hubs and repeaters were used much more than they are today. Anymore, switches are the standard rather than hubs. One of the reasons is that switches split up collision domains. With a hub, every device connected to it is on a single collision domain. With a switch, each link and the switch itself are on separate collision domains, so collisions really never happen. When a collision does occur in a collision domain, both devices stop transmitting, they send a jamming signal to notify each other that there was a collision, and they wait a random period of time before verifying that the line is idle and retransmitting. Now, this may seem a bit elementary to some taking this course. Just keep in mind that one of the purposes and objectives of this course is to prepare you for the JNCIA Junos exam. With that in mind, we will at least touch on all of the JNCIA Junos exam objective topics to that end. Alright, so let's move on.